Good morning. When I bought this van, one of the things I noticed fairly quickly was it had a retarder, which I shall show you later on. What I also discovered fairly quickly is it didn't work, and the reason it didn't work was because the control box for it was missing. There were some cables underneath the van that had been tied up. There was a damaged cable that hadn't been secured safely and had been caught up with the rotating parts of the drive shaft. When I got hold of the electrical wiring diagrams from WOZ, the manufacturers of this van, I quickly understood how the retarder was managed, and it's controlled by an electronics ECU, a thing called a PSM, that's under the driver's seat, and that ECU provides CAN bus conversion information for the Genesis system, things like doors open and reversing lights and stuff like that, but it also provides the control for the retarder. The retarder on this van is a three-stage retarder. In other words, it uses three separate relays to increase the amount of retardation to slow the van down. The Iveco that I filmed a couple of weeks ago, that's on a separate playlist on my channel, also had a retarder fitted. That was a factory fitted unit, and it had a dirty great big control box in the glove box by the gear lever. I was expecting initially to find a similar control box, control ECU, in this van. And it was only studying the wiring diagrams I realised that everything was done by this PSM, this central Mercedes-Benz add-on unit. I think they make it available for converters. Now, I've always wanted to get it working. So the first thing I needed to get hold of was the control box. Without that, I wasn't going to get anywhere. They're not particularly complicated. I'll have another slurp of coffee. They're not particularly complicated, and I've got one here. That is a standard three-stage, three relays, Telma control box. Let's see how well that films. He says trying to not to, right, there you go. So currently I've got all the cables out, and you can see it's all nice, clean and white and lovely, lovely, lovely. It wasn't in this state when I got it. I've had it all apart, I've cleaned it all up, I've checked everything. And the important thing to understand about the way these things work is that there's a dirty grate terminal there, where 12 volt comes in, and there are control signals over here, numbered 1, 2 and 3 I think. Yep, 1, 2 and 3. You'll see, I think you'll see that number 4 is blank. Those are the control signals from the PSM module. Under the seat there's an earth connection at the top there, and there's one marked V down the bottom there. That is the output that goes to an orange light on the dashboard, so that when any one of these relays, or any quantity of these relays, is engaged, there's a signal comes out on V, and the way they do that is there are diodes. They take a diode output from each one of these relays, and therefore that keeps some isolation between the outputs of the relays, so that you can run one light bulb from three different sources without any causing shorts or anything like that. There's also dirty grate diodes connected across the outputs of these relays on a panel behind this black plastic. That's prevent reverse EMF, to prevent any possibility of either damage to the relay itself by sparks, or damage to the control units. There are also diodes connected to each one of these inputs as well to protect as well. There's also diodes across the coils, and diodes are just a way to get rid of the current when you disengage a relay. And all those need to work properly on these things to avoid damage. And this box, I could have built something very, very similar to this. I didn't. I paid more than I wanted to for this, but I could have made something. But this is an all-in-one bit of kit. It's in a plastic box. It's got good terminals on it. The relays are properly rated. And one thing that's interesting is just, he says, look, where is it? Just there, there's a fuse. The output contact of the relay is fused. It's just a strap fuse, but there is a fuse there. these relays are rated to probably about 30-40 amps, and the current that each coil in the retarder draws on this particular van is 25 amps, so that's probably a 30 amp fuse. And if you look at, I don't know if you can see it or not, look at that one there, you can see little tails sticking out. There's actually some spare fuses bolted on the side, which is, that's just nice they provided that. But this box, with this box, I can make the retarder work. I've already tested this box works. It looks a bit crappy. I mean, there was a lot of muck inside here when I got it. The springs holding the contactors for the relays were a bit rusty, but it functions, and I've tested it and it operates. There's not too much pitting on the contacts, although I will give them a slight, was a bit pitting on that one. I'll give that a clean up. All these parts are replaceable. Telma, they have a very good, you know, you can get documents and order replacement parts almost down to individual springs and clips. So I've now got this box and a lid that says Telma, and I've got the cable as well, but obviously I've taken it all out because I've dismantled the whole thing just to clean it all up, because it was covered in diesel smuts and sort of crap. Now, that's half the story. Box. The wiring under this van was designed for a similar box, but with a slightly different connector layout, so I'm going to have to hardwire this box in. But as part of the exercise to get this up and running, I thought I'd better check the actual retarder out first, and I did a resistance check across the coils in the retarder, which I will be showing you later on. There are 6 coils in this retarder, north and south. They're in 3 banks, 3 relays, 3 banks, but there are actually 2 coils in parallel connected to each relay, north and south. And that effectively a coil at the top and a coil at the bottom, because when you apply a magnetic force to a rotating disc, you want to pull it equally in both directions. Otherwise you're going to get some deflection. At least that's my thinking. One of my coils seems to be open circuit, as best I can tell. The coils are wired in parallel, so I'm seeing half an ohm across 2 pairs of coils and an ohm across one of them. That suggests I probably lost 1 coil out of the 6. That's a shame. It means I've got to take the retarder apart and have a look at it and potentially replace a coil. It's not the end of the world though, because ever since we've owned this van, there's been a bit of a scraping noise, there's been a grinding noise, and at one point I did think about taking the retarder off, because I'm pretty sure it's the retarder that's making the noise. I did think about taking the retarder off and just fitting a straightforward prop shaft under the chassis. Prop shaft, original prop shaft for one of these sprinters is about £400 I think. If I can repair the retarder and get it all working for less than that, then I'm quids in. And I've also got a very useful bit of kit. If you don't know what retarder is, there's a couple of videos, I may even link one in the description, but there's some videos that explain how they work. But they're effectively an electromagnetic brake. You energise a coil, that creates an electromagnet. The electromagnet reacts on the rotating rotor, either end of the retarder, and that creates resistance and braking. And the power curves on these things are incredible. When all 6 coils are energised, that's putting the best side of 100 amps off the battery, but that's the equivalent of about 350 newton meters of torque. That's a lot of braking force. Potentially 80% of the braking of the vehicle can be done by the retarder. That saves on brakes, and it's a fantastic bit of kit to have. You imagine I'm up in the mountains somewhere and I'm getting brake failure because we're coming down a steep pass. I'm thinking of Applecross, for example, or some of the mountain roads in Europe. I don't want to rely totally on the brakes. I'm sure they work fine, but this is an automatic vehicle. I can't use engine braking in the same way you do with a manual vehicle. It does give a degree of engine braking, but I'd much rather have that safety mechanism of this fantastic gadget under the van doing the same thing. So my aim is to get it working. As I said, unfortunately it looks like I've got a 40 coil, and there may also be some grinding noises coming from the retarder, and that's down to the way the stator plates at each end are in proximity to the coils themselves. There is a minimum air gap that should be between each end, and it's only small, 1mm. It's not a massive air gap, but I think my air gap's looking a bit tight in a couple of places. Now that could be there's some damage, there's some distortion in the stator plates at either end, or it could be that it just needs shimming out, and they provide a shim kit specifically for setting the end gaps on these things. So it's going to be worth taking it off and overhauling it. And this video, this introduction, is really because there is nothing on YouTube at all covering these devices that I can see. You know, there's a few demonstration videos from the manufacturer showing you how they work. These are very popular, they're used extensively in lorries, but there's not a great deal of information about them. So this video should be what mine does, what I do to fix it, what I have to do to take it apart, do I have any problems getting to pieces, do I have any problems getting parts. Telma is a French company. Their website does not list parts or documentation. They don't have a tech support library at all on their on the manufacturer's website. There's a telmausa.com website, lots of documentation on there, and there's a couple of UK distributors. I'm in the UK. A couple of UK distributors that provide parts, or at least they provide a source of parts, I hope, and I will almost certainly have to buy at a minimum probably a coil. I may be lucky, it may just be a broken wire, unlikely, but I'm probably going to have to buy a coil. I think I may well need a shim kit because it does look like I've got to do some adjusting. Excuse me. What else? I'm missing one of the things I did notice is where they'd taken the white box off. I'm guessing the ambulance service, or maybe the dealer, I don't know, took the white box off because these have a value of they're £600 to buy new, or $600 or so obviously the white box was taken off for a reason, probably the spares. I think if they had just disconnected it because the retard was causing vibration or something like that because the coil had failed, they would have just unplugged it. I think what I'll do is just pause here. I'm going to film underneath the van and just show you the box itself, the actual physical retarder, and then I'm going to have to take the thing off, which should prove interesting. It weighs 70 kilograms. Not a pleasant task, I don't think. Probably not as unpleasant as taking gearboxes off. I hate taking gearboxes off, but this thing's quite heavy. I'm hoping that I can overhaul it, get it working, get it up and running. Not much else I can be doing at the moment. I can't get on with the crafter until I can buy some parts, rather buy some building materials, and you know, there's nothing locally available really. So for now I'm playing with this van, and with a bit of luck, as it, I can get the retarder going, and it's just another feather in the cap. I've done something else that I hadn't intended to do, didn't know anything about, and I've learned a bit. The other reason why I'm playing around with the retarder is I've painted the floor of the crafter. I need some insulation and some plywood to finish it. I've refitted the trim, and I've pulled the cabling up for the reversing. Not reversing, start again. I pulled the cable up for the tow bar. That's now all tucked away, ready to wire in at a later date. And what I've also done over here, it says, moving the camera out of the sunlight, is I've got was up on my jack stands. That was fun and games getting it up in the air on this gravel, but I didn't want to take the crafter out again from under the carport. So was it up on jack stands, that gives me the ability to actually work under it a bit more safely. You'll see that block behind that jack stand. I'm just supporting the inside wheel as well, just to take the strain off these two outer tyres. And you'll notice the dogs peed up the wheel. Dogs, I don't know. Right, let's get under the van and show you the retarder itself. So a bit of perspective, ground level. This is the retarder. Now is that going to focus? There's the retarder. This part here is bolted to the drive shaft. There's an identical or a similar plate on the other side of the drive shaft. So effectively you've got a short drive shaft there, a short drive shaft there, retarder bolted to the chassis, on rubber isolators in between, and the electromagnets, which are behind these shoes here, 6 of them, when energized, prevent or try to prevent this plate rotating, and that transfers into a braking effect through the rear wheels. The retarder only works for the rear wheels. The relay box connects, or the relays, via the wiring in the relay box. Each relay connects to one of these. You can see there's actually 4 connections there. That one's unused, no cables coming from it, and each one goes to 2 individual cables, because there's a dedicated cable for each coil, so there's 6 coils inside there. There's a rubber shoe that goes over that for the cabling, and there's a cover that goes over the top of this, and I don't have the cover, so that's an item I've got to buy. Basically this is exactly how it looked when I bought the vehicle, just like that. It had all been disconnected. The relay box that mounts on this metal plate here was missing, and all these cables, which are dangling down now, they were all just cable tied up there. And I think, having looked at this round connector, is that going to focus? I can't tell whether it's focusing or not. I don't think it's been plugged in for a while, so I think this has been disconnected for some time. Now, the air gap I was mentioning is there between this plate and the stator, where the stator plate, there's an air gap. Should be 1mm. Under there, it's not so. I think I may have some scraping between this stator and these, either on this side or the other side. So as part of the exercise in identifying whether I've got a faulty coil or faulty wiring, I'll also try and get this air gap right. There seems to be not a very good gap here and a bit of a gap up there, so there may be some float in the bearings. It may actually be the bearings have failed. So it's all going to be an exercise. Now, what I should do shortly, I have no idea if this is in focus or not. Oh, it's annoying. It looks out of focus in my eyes, but my eyesight's not so good. I will connect a battery to each one of these terminals in a minute and just show the difference in current between a good set of coils on that connector there, a good set of coils on that connector there, and what I think is a dead coil on that one there. There's no point showing the resistance measurement because I don't have a resistance meter that is really accurate enough. They're supposed to be about 0.8 of an ohm, but all I can see is slightly less than a short and a slightly higher resistance than this one. But just doing that with the resistance meter gave me a fairly good indication that I probably had a problem here. Now, removing it. 4 nuts there, 4 nuts on the other side. If I'm lucky, there's enough movement on the splines and the shaft here that this will pull back. Then it's unbolting these 4, and I should probably do these ones. Well, we'll do whichever ones are easy to get at. I'm thinking possibly there are slots in these ones here, and these are adjustable, whereas these aren't. So I'll probably take these ones off here. Jack underneath. Lower it down. As I say, this thing weighs 70 kilos, so I'm gonna struggle to get it out without having some kind of wheeled something or other to pull it about on. And then it's, from the best as I can work out, they are fairly easy to dismantle. But let's play around with doing some current checks. So for this little experiment, I've got the original harness, nice big thick heat proof cable in there. That's the original output harness from the relay box to the retarder. That's connected to all 3 of the coil packs. I've got my battery jump lead connected to stage 1, or the first pair of coils. There's a current clamp there set to DC, which I shall zoom in onto, and just need to zero it out. There's no current flowing at all at the moment. And you should see that as soon as I connect the battery, which I'm just going to do now, 25.6 amps. Okay, so that's the first stage. That's what you expect. The spec sheets for these retarders are fairly comprehensive. That's what you expect to see. Disconnect it. The retarders have actually got heat shields. When all 6 coils are energised, there's quite a lot of heat being generated as well. They're pretty substantial bits of kit. Right, so I shall now connect it to the second coil back, and you'll see the difference, which I think is the grey one. Grey. Yes, the grey one. Moved it. Still in. That's better. Right, now this one, this is changed overnight. There you go. 11.8 amps, 12 amps. It's only one coil working. That's a shame. But that's a very easy way to check whether these things are functioning properly. And that's the reason I've got to take the thing apart. So that concludes probably part 1 of this how to play with the retarder exercise. I'll do a part 2 taking the thing off and the initial dismantling, and then part 3 will probably be some weeks later when I manage to get hold of some parts. Thanks for watching.